next slide, please, Ella. Thanks.
Yeah. So the way today is going to work, we're going to start by introducing our panel of experts who we're very grateful to have with us here today. Then Jamie and myself will give an overview of the paper, focusing on the background, the methodology, and the key results found. And then, differing from a standard format of a journal club, we're going to be handing over the majority of today's session to our panel. Jamie and I have prepared some questions which we hope will provoke a lively and interesting debate building upon the themes of the paper. Throughout, we enthusiastically welcome any questions from our audience members, and we'll be putting these to the panel.
Brilliant, thanks, Ella. So I'll just go through our fantastic panel. So chairing is Dominic, who has a very cool job title of being a professor of visual psychiatry at King's, and is a world expert on visual hallucinations. We've also got Mitul, who is a professor of neuroimaging and psychopharmacology at King's, and he was also the senior author of the paper that we'll be discussing. And we've got Dag here as well, who is the chair and a professor of old age psychiatry at King's, and also a Parkinson's disease expert. And from Italy, we've got Marco, who is a professor of neurology at Annunzio University in Chieti in Italy, and Daniel Collerton, who is a clinical academic psychologist from Newcastle.
So the background of the paper is visual hallucinations in Parkinson's disease, and we know that these exist on a spectrum of severity, as illustrated by this diagram on the slides. We know around 70% of Parkinson's patients are affected by visual hallucinations, and these are more common in more advanced stage of the disease. These are thought to be not just an iatrogenic effect of dopaminergic medication, and importantly, they're predictive of poor disease outcomes, notably cognitive decline leading to dementia and nursing home admission. Previously, prior research has been limited by heterogeneous methodology, which has led to a wide array of inconsistent brain regions being implicated in the visual hallucinations mechanism in Parkinson's.
Brilliant. So a way of kind of addressing some of the inconsistencies in the pre-existing research this study tried to address was to identify both the structural brain alterations, but also variations in neuroreceptor function in individuals with Parkinson's disease with visual hallucinations. And in terms of the methodology that they used, it was quite a complex method, so I've tried to distill it down. It was a really large-scale mega-analysis, which kind of divided people into two groups. The first group was individuals with Parkinson's who had visual hallucinations, just over 100 or so, and those who didn't, and compared these groups in terms of outcomes, including cortical thickness, surface area, subcortical volumes, and then compared the structural brain analysis with neuroreceptor alterations, largely through PET imaging data. They also controlled for other covariates and potential confounders, including cognition data, severity of Parkinson's disease, and also where it was available, the period of hallucination onset, and also the severity, which was measured through neuropsychological batteries. And as I previously said, they correlated all the structural changes with, they mainly looked at serotonergic and dopaminergic receptor density compared to some of the structural changes that they found. And a way of synthesizing what the overarching brain areas that are responsible for visual hallucinations were, they used a principal component analysis to identify these clusters and group them into a group level analysis between individuals with hallucinations and those without. They also used a structural covariance analysis to establish which brain networks may be malfunctioning in individuals with visual hallucinations.
So the key results of the paper, they found that in patients with visual hallucinations, there were widespread reductions in cortical thickness and surface area. Two distinct regional components were found for cortical thickness, which are illustrated in this figure, which is from the paper. So we can see in the purple dimension that the frontal region, in particular, the superior frontal gyrus and the right middle frontal gyrus were affected. And we can see in the green dimension, the occipital region, notably the cuneus and the right occipitotemporal gyrus, were affected. This reduced cortical thickness, which was found predominantly in the parietal, temporal, and occipital regions, was associated with the severity of the visual hallucinations experienced by the Parkinson's patients. So they found that the dopaminergic and serotonergic receptor alterations were associated with the observed morphometric cortical changes. They found an involvement of the hippocampus and the amygdala, which were importantly independent of cognition. They found that the early brain regions involved in the visual hallucination mechanism were the cuneus and the superior frontal gyrus. And they found that the predominant brain networks that were involved in this process were the attention networks, the dorsal and ventral attentional networks, whilst the default mode network was relatively preserved throughout.
Thanks, Ella. So just to draw out some of the key points and give an overview. So the authors found that it was quite a wide extent of cortical involvement in individuals with visual hallucinations. And some of the cortical involvement changes were correlated with visual hallucination severity, which is assessed through psychological, neuropsychological batteries, giving a kind of dose-dependent response in some of these regions. They also used a structural network analysis showing that the attentional control network seemed to be particularly implicated in visual hallucinations in this cohort. And there's a role, a potential role of the hippocampus too in the pathophysiology. Dopaminergic and serotonergic receptor density maps suggested that neurotransmitter loss in these pathways could be linked to some of the observed cortical changes. So we'll now hand over to Dominic to chair some of the discussion. We've got a few discussion points already, but very happy to take questions from the audience and to guide the discussion from there.
Right, thank you very much. Particularly to Jamie and Ella for inviting me to chair this. It's a great honour to chair it. It's an exciting panel. I'm looking at the pictures. I think I can see most of the panel there, but maybe if the panel puts on their cameras so that they can be seen. So just by way of a sort of brief preamble. I think Ella did mention it, but some of you in the audience may be asking, well, why has all this effort been put into studying visual hallucinations in Parkinson's disease? Because, I mean, we're all interested as neuropsychiatrists in you know, neuropsychiatric symptoms, and visual hallucinations are a good one. So it'd be great to know, you know, what's causing them. But it seems a lot of effort to put in to study this particular symptom, and the reason was given, and it relates to the fact that these symptoms are turning out to be biomarkers for poor cognitive outcome. And it turns out that this year is the 20th anniversary of the first paper. So Dag is in the audience. Dag wrote the first paper on this in 2003, where he spotted that there were people with Parkinson's disease who had visual hallucinations, had worse cognitive trajectories. And it's a widely replicated finding, and we don't know why. And if you just think about that for a moment, well, why should a psychiatric symptom, a perceptual symptom, be linked to dementia? Why should it predict dementia? And obviously, if you can work out that link, you might get a handle on what is it in Parkinson's disease that's leading to those poor outcomes. Not everyone will get such bad cognitive impairment. Everyone gets a bit of cognitive impairment, but not everyone gets as bad cognitive impairment as the people that start off with visual hallucinations. So that's the real driver for this. And Ella, I can't remember if it's Ella or Jamie, pointed out this is a mega-analysis. Now, some of you might not be familiar. You all know what a meta-analysis is. And that would be in imaging terms, where you would go and have a look at the blob coordinates of each of the studies that have reported these findings and put them all together and come up with a kind of average blob or some sort of summary statistic of the blob. But in a mega-analysis, you go back to the raw data. So basically, the huge amount of work that went into this Miriam's paper was to go back to all these international groups, get access permissions to the original data, and put it all into an analysis, and then try and harmonize, and that's a technical term in terms of how you deal with different scanner types and varieties, and how you deal with the different types of clinical data. Although in Parkinson's disease, it's quite standardized, the types of assessments people get. So everyone gets a UPDRS. Most people get an MPI to measure neuropsychiatric symptoms. So there were some kind of questionnaires and cognitive assessments that were the same across all of these different groups, and therefore we could use those in the kind of analysis there. So that's my kind of preamble to what's different about this paper, and it basically brings together lots of different international studies that have asked the same question, all come up with actually slightly different answers. And so the idea was, well, what is the correct answer, and is it all to do, or is the variability all to do with the way that you've controlled for different aspects, or what your group control, your hallucinated versus non-hallucinated control groups are, and that kind of stuff. Okay, so let's go through the questions, and after each one I'll pause and I'll ask Jamie and Ella if there's any online questions linked to it. So question one, what's the timeline of the brain region involvement relative to development of visual hallucinations? So I can partly answer that in a small way. So the patients we looked at here are all early Parkinson's disease. So that this is not late Parkinson's disease dementia. This is all relatively early. And I think our MMSE cutoff was they had to have cognition greater than 25. So some cognitive impairment was allowed, but these were relatively early stage patients with Parkinson's disease with or without hallucinations. But to know what the time course is, you've got to wind back the clock. And there are a few studies that have done this. There's one study that's looked at very early symptoms, minor hallucinations. So these are things like presence hallucinations or passage hallucinations, where you see something flitting in the corner of your eye. And they've found some structural changes already at that point. And in particular, the precuneus, I think, was one of the regions that was kind of overlapped with our findings. And then a study that we did ourselves was the link to the Parkinson's Progression Markers Initiative, PPMI, where we looked at patients who had just been diagnosed with Parkinson's but had not yet developed any symptoms. So this is like 2 years before they'd developed their hallucinations or minor hallucinations, illusions, etc. And at that point, 2 years before you even start to get formed hallucinations, you already have some of the frontal lobe changes that were identified in this study as well. So that gives you a little bit idea of the timeline in terms of structural changes. But maybe can I pass over to Mitul well, let's just start with Mitul then. So the other techniques we use, I don't think, as far as I know, people haven't looked at Alzheimer's progression or other conditions to say what happens early on in them or what happens before the structural changes. But do you have anything to say about whether the kind of covariant stuff that we did or the other types of analysis we did, if there's any evidence to show earlier changes than the structural ones?
So you're right, there's been very little in this area. Dominic and I actually have a student who hasn't published her work yet, but she was also looking at the PPMI data, seeing early functional changes, but that was an analysis of the scan closest to the first experience of hallucinations. And you see a network in the superior part of the brain that seems to be associated with those early experiences. But there's nothing else in our data or our analysis that speaks to longitudinal changes. This is very much a cross-sectional analysis. So that's definitely worth highlighting. It's a huge study and a huge amount of work, but it doesn't answer every question. So we're not able to look, we have not looked at changes over time in this study because the data doesn't have multiple time points. Is there anything else you think we could add to that, Dominic?
No,
or anything else you were guessing at?
Yes, I think the answer is we don't really know from Parkinson's. I guess Dag as well. I mean, you've been involved in hundreds of studies of early Parkinson's and the progression and things. But as far as you know, there's nothing. There are no sort of general, very early structural MRI changes that occur in Parkinson's that predict psychosis or even cognitive changes that you're aware of? Are there?
No, I'm not aware of that, Dominic. That doesn't mean I don't exist, obviously, but clearly doing these longitudinal studies is always more challenging. But then we have resources such as a PPMI that can be looked at. So clearly, the development of the course question is important. But I just wanted to go, if I may, go back to your one comment to your brilliant introduction, Dominic, and you argued for the reason for why this is an important question, the visual hallucinations of Parkinson's disease, and thank you for mentioning our early paper. But I think we should forget the importance of the symptoms in themselves. We have many patients coming to the clinic who struggle with these symptoms, and not everyone, not every hallucination is a problem, but they frequently are. They can be distracting, disturbing, frightening, and they can evolve into frank psychosis with delusions and agitation and all sorts of things, including hospitalization. So they are also important as a clinical phenomenon in themselves. And of course, then treating them with symptomatic therapies is also important. So in addition to being a marker of dementia progression, it's also an important clinical symptom.
Yeah, I fully agree. Marco as well. So you've had an interest in kind of early prodromal symptoms and this kind of stuff. Anything imaging wise that you know of in very early Parkinson's that then might be linked to later visual hallucinations and psychosis?
No, I don't have any evidence. But let me ask one question. I think that now that you have collected all this big data, you can really answer through a follow-up. You can answer to many questions on the progression of hallucination. My basic question would be, how much does an early hallucination predicts the development of formed hallucination, and which time these formed hallucinations do develop? In a study that we had done in 1998, 96, something like that, we were studying in a virtual reality the patients which were at the beginning of their Parkinson's disease, and we could observe that they were producing pareidolias during the virtual reality activity, and we are programming recording of functional MRI during this project. But the point is that there are some Parkinson patients which do have early hallucination, early simple hallucination, or pareidolias at the beginning. And how much, I do not have the answer, how much this early pareidolia or early simple hallucination do predict, and in which time the development of the more complex hallucinations, the ones which are endowed with narrative. I do not know that if that's just the question. Then I have another question. It is on the, you said that you had very early patients in your selection, but the amount of levodopa equivalent doses on the average that they were taking is not that low. It goes on an average of more than 400 milligrams in one group and more than 900 milligrams in another group. While in the average at the beginning of Parkinson, we never use more than 300 milligrams levodopa, so we should add that a quite minor amount of levodopa taken if the patients had to be classified as early Parkinson.
Yeah, so that's maybe a misunderstanding. So the when I was talking about the very early stuff, that's the PPMI data where we looked at that. But for this study, no, they would have been, they were early in the cognitive trajectory rather than in their Parkinson's. I can't remember what the average length of the Parkinson's was, and it varied in different studies. But you're absolutely right. These are all established Parkinson's disease patients, but they just hadn't got. They hadn't gone down the dementia trajectory yet.
Yes.
And in regards to, I like your virtual reality. I remember your virtual reality paradigm, and I think there's lots of groups now looking to see whether pareidolia does really predict the transition later on to the kind of PD psychosis with the other formed hallucinations and the later stages of loss of insight and this kind of stuff. I haven't seen any evidence to say whether there's a definite progression or whether some people with minor hallucinations, so for those of you who don't know, that's illusions and passage hallucinations and presence hallucinations, which is the big one, where you have a sense that someone's sitting next to you, so it's not visual per se, whether those invariably lead to the cognitive progression, or whether that's a slightly separate entity. My hunch is that they are all on a spectrum, and then this is all part of a progression, and they probably all do predict some form of bad outcomes. But I don't think there's good evidence out there to say that's definitely the case. Oh, Dag, you wanted to say you wanted to ask something?
Yes, thank you, thank you. So I wanted to follow up on Marco's good point regarding levodopa dose, and we heard Ella correctly say initially that the hallucinations are no longer seen as merely a side effect of dopaminergic drug. I remember when I started this in the 90s, I think Marco and myself, we were among very few people interested in this topic, and I remember being really annoying as a neurologist. I were offended by psychiatrists coming telling them that their patients had psychosis. Anyway, we agree that it's not only levodopa side effects. However, we also know that it's clear that levodopa dosage has an effect. So we know that when you increase the dose, symptoms can emerge, and when you get over the dose, the symptoms can go down. So I just wanted to ask how that was handled in that paper, because I mean, in this big group, there must be some people who had at least their hallucinations released by higher dopaminergic drugs, whereas others maybe were on a much lower dose but still had hallucinations. So I guess it's a mixed bag here in the people with hallucinations.
Yeah, so Dag, we had enough numbers that we could covary for LED-D. So what we can say, this is not explained by levodopa dosage or levodopa equivalent dosage. But I mean, all of the participants were on L-dopa, but the difference between the hallucinators and non-hallucinators could not be explained just by the dose.
Okay. Do you think that is sufficient to kind of rule out an effect in itself, or just that it's not kind of on a group level is significant? My point is more that it might be individuals.
Pragmatically, yeah. You can't do studies on patients without Parkinson's therapy. So you're always going to be stuck with that potential problem.
There is a study done by Chris Getz. I think it is also an early study in the 90s, where he was challenging levodopa doses in order to see whether the increment was modifying the frequency of hallucination. It's an old study, I guess. I don't even remember where it published it.
And he found no association that they didn't release hallucinations, right, Marco?
Yeah, he didn't.
Okay, let's just get Daniel's comment, and then maybe we should look at we should move on to the next question at some point. But Daniel, and then we'll go for the if there's any chat questions.
Yes, thank you very much for inviting me. A very nice paper to discuss. I think what this particular discussion about the longitudinal development of symptoms raises is what is the relationship between these different forms of experience. So I think there is often an assumption that there is a continuum from minor to formed complex hallucinations, or from illusions into hallucinations. And I'm not myself confident that there is that quantitative difference, that a hallucination is just a more intense illusion. I think you can make an argument that they are kind of orthogonal experiences, and that a hallucination may be the brain's attempt to not have an illusion, for example, so that there's a trade-off between these different types of experiences, rather than the more illusions you have, the more hallucinations you have, and vice versa. There's a possibility that the more hallucinations you have, the fewer illusions you have. And I think that's an interesting way of trying to bridge what we see in these trait studies, where we're looking at why people are liable to have hallucinations, bridging those into the state studies, which I'm sure we'll come along to talk about, which is, well, why do these experiences happen some of the time and not all of the time? So that was my comment.
Okay, excellent. Shall we move to any chat issues, or next question over to you, Jamie or Ella?
Yeah, we've got one interesting question in the chat from Ishak, which actually relates to one of the questions Ella and I posed. I think the 5th question. So Ishak's asked, how does this data compare with the presence of visual hallucinations in other psychiatric disorders? So I think our question is very similar, but very slightly differently. That how specific are these findings to Parkinson's disease visual hallucinations? For example, if we included a 3rd group in this study, so people with dementia with Lewy body, or with other psychiatric disorders or organic neurological disorders resulting in visual hallucinations, how specific would these changes be to Parkinson's disease?
Well, I can first of all say that, of course, no one's done mega-analysis in Alzheimer's disease or any of the other conditions where you get visual hallucinations. I don't really have, I don't know how to answer that. I'm sure there's some areas or some mechanisms that will overlap with other conditions and others that will be specific to Parkinson's. But I think one thing is important to say, that the biomarker aspect, the link to saying if you've got visual hallucinations, you've got poor cognitive outcome, that is true of all the neurodegenerative diseases. So certainly true in Alzheimer's disease, and the only and it's also true of schizophrenia actually, but probably for different reasons. Remember though, Charles-Bonnet syndrome, that's close to my own heart, so that's eye disease causing visual hallucinations, so that doesn't have these implications because it's got a totally different mechanism. But I think for all the neurodegenerative ones, it is it's also valid. But whether the MRI blobs and all the kind of other elements are the same, I'm not sure we can answer that. Mitul, do you want to say something about that? I know from Miriam's sort of kind of things she's working on at the moment. Is there evidence that in Alzheimer's disease, for example, you get similar changes, or I don't think people know?
Sure. It's a very brief answer, that we don't know. However, we have collated a sample from colleagues, some in this meeting around the country, of individuals with DLB, and we're running that analysis at the moment. We ran a pilot analysis with a small sample, and there is some overlap in the regions that come up. Some of the subcortical regions are the same, for example, but I don't think the sample size gave us enough confidence to really, for me to be able to describe what we found yet. However, we've doubled the sample size now, and so within about a month or so, we should know what happens in DLB. And what we've done now is we've taken the group that we have already of patients with Parkinson's and visual hallucinations, and we can plug them into the analysis as well, so we can compare them directly as well. Alzheimer's disease, Miriam's actually in a fellowship interview now, and part of her fellowship would be to look at this question as well.
I can say that in 2014 we published a smaller study on Lewy body disease, and we got the same finding that Quinius was involved. We did this cortical thickness studies, and we compared Lewy body disease with Alzheimer's, but the numbers are small. Findings, we were surprised to see the same areas involved in your study.
Yeah, well, I mean, that's correct. Yeah, and what we want to do really is try to understand what those differences mean, how they connect in with brain networks, how they connect in with neurochemistry as well. And that's where the bigger sample sizes gives us the confidence to run those analyses. But it's great there's some overlap, even with the small sample sizes. It shows that, I think it suggests that some of the effects are quite large.
So just as a small, Dag can probably speak to this more than I can, but the obviously in dementia with Lewy bodies, we're looking at a mixture of Lewy body pathology and some Alzheimer's pathology. And there is some evidence that in the Alzheimer's disease patients that have visual hallucinations, they've also got a bit of Lewy body pathology. I don't know, Dag, in Parkinson's disease, is there Alzheimer's pathology in the people that get cognitive impairment? I think so. So it could be that actually the hallucinations are marking this particular subgroup of people that have got combined Lewy body and Alzheimer's pathology. So you would expect perhaps that there would be similar structural changes and functional changes in those patients that have visual hallucinations.
Can I comment on that? Thank you. Very good point. And I would be surprised maybe if the let's say the pathology underlying hallucinations would be strongly related to Alzheimer's type pathology, because to me the hallucinations is such a really pathognomonic feature of the alpha-synucleinopathy. That's really a symptom when it occurs in a person with no other symptom, an older person with no other symptom, but with visual hallucination. That to me is such a strong signal that this person will develop either Parkinson's or DLB, and there is some evidence that that is the case in people who have been followed up. So to me, this is a really clear Lewy body sign. But then, when comparing Parkinson's and DLB, I would be surprised if there were differences. So I think Marco's findings makes a lot of sense, because from a clinical perspective they are identical. I mean, you cannot kind of distinguish these symptoms. Maybe the minor symptoms are more typical in Parkinson's. That might be because we see the patients early on with these phenomena, because they have Parkinson's disease as the first step, and then we have them in our offices, and then we ask these questions. They occur with us. The DLBs, when they come to us, they usually have already a full-blown syndrome, so we haven't really seen them in the early stages. So, but in essence, to me, the hallucinations in Parkinson's and DLB are very, very similar from a clinical and probably also from a pathological substrate. Whereas in Alzheimer's, I would be surprised if they are not different. But that's up to Mitul and Miriam to find out.
Just as a comment for the clinicians in the audience. So Dag did a big post-mortem study, neuropathology study of DLB, of correlating in vivo diagnosis and what happens post-mortem. And the patients that were diagnosed as having Lewy body dementia, but at post-mortem it turned out they had pure Alzheimer's disease. So they met all the clinical criteria for Lewy body with visual hallucinations. Those are patients that had eye disease. So it's a learning point. If a patient has eye disease, that's another reason, an independent, non-neurodegenerative reason for getting visual hallucinations, and it can put you on the wrong track in terms of your diagnostic criteria. Okay, Jamie, shall we move on to the next question?
Yeah, I'll move the slides back because we've jumped ahead.
Yeah.
Questions from the audience.
Number 2, how do the observed structural and functional differences relate to the severity of visual hallucinations? So just a small comment here. So remember, we're quite limited in what scales we can use in this mega-analysis, because we could only use ones that all of the studies had done. And there aren't really severity or not. The severity measure in the neuropsychiatric inventory is quite specific. It multiplies a kind of distress scale with a frequency scale. So that's what is meant by severity in our mega analysis. And I think we did, I mean, unfortunately, Miriam's not here, who knows all the micro details. Mitul, you may remember, but we did find some links with MPI severity scale and atrophy in, I think, in the parietal lobe, in a particular area of the parietal lobe. Mitul, can you remember anything?
Yeah, that's correct. But you have to remember that the correlations with the MPI score were in quite small regions, nowhere near the size, the scale, and the network properties of the regions that we discovered difference between the group. And I think it's important to remember that we don't have a model of how NPI scores, that severity or frequency, should relate to brain structure. You know, is it a linear model, or is it a non-linear model, or is it a threshold model? So, of course, we'd want to do the correlational analysis, but the correlational analysis assumes a very narrow and specific model of these relationships, and we simply don't know what the correct model is. So there's more work to be done there.
I think another thing to say, so the standard measures also look at how long a hallucination lasts and how often it occurs. And some of the newer visual hallucination scales look at that separately and combine that as their own kind of measure. And it in some recent work we've been doing with Fabrizio D'Antonio in Rome, we've shown that there are actually different neural correlates of how long hallucinations last and how frequently they occur. So I think severity, we need to have a more nuanced concept of what we mean by that. And of course, what we haven't been talking about is how emotionally distressing it is, you know, how distressing it is, which is kind of intuitively what you would imagine severity should be measuring. And again, we haven't got any evidence from our mega-analysis as to which brain regions might be linked to how distressing it is. But my suspicion would be, and maybe I'll ask Daniel on this as well, because I think we've had some data related to this, but it could be something to do with insight. It could be that you know, how much you understand its hallucination might define how distressing you find it. But I think Daniel, there are counterexamples to that, aren't there? There are people that who lack insight, who don't find it distressing at all, and vice versa. I think you need your mic off. Hand up, but mic off.
Apologies. You'd think we would all be used to it by now. I think that's very right. That insight is quite a slippery concept to get hold of, and is also quite variable. It's not that you have it or you don't have it, but it can be quite fluctuating. And to my mind, it's a separate thing from hallucinations. So that some people have hallucinations, other people with apparently exactly the same hallucinations may have a very different psychological understanding of them, which I guess we would think of as insight. I suppose just to go back slightly to what Dominic was just talking about, I think it's quite probable that there are different factors which are involved in why a hallucination starts, why it then persists, and then why it ends. So if we're trying to think about, well, what is the cause of hallucinations? Actually, we're probably thinking about at least three separate factors or three separate groups of factors, which are about why a hallucination is triggered. And that might be something internal or something external or some interaction. Why it then continues, and why it continues for the length of time that it does, and then what happens to switch it off. And I think when we're considering that, going back to what Dominic was just saying about perhaps different neural networks being involved in how frequently they happen, which is about how often they're triggered, and then how long they last, which is about how they can persist, and then what occurs to switch them off. I think that's going to be a very fruitful avenue to be looking at in the future.
Okay, Jamie or Ella, are there any chat questions related to this one, or shall we move on to the next?
No questions at the moment from our audience, so we'll move to the significance of the...
Since I was listening to Dominic, and I had met him in a meeting in Newcastle some years ago before COVID, and I'm always curious, why aren't we presenting a scale for hallucination? Because we really need a scale, which should be coming from a general agreement on which are the most relevant items in terms of duration, frequency, time of the day when they appear, and mostly to me, and this is quite my idea fix, is the narrative content of that, whether the hallucination has a cinematic content and the narrative content, or it has no narrative content, it's just an image moving and passing. So wouldn't this be the last occasion to try to prepare a scale and present the scale to general audience? What do you think?
Yeah, no, I think so. Daniel and the his Newcastle colleagues have been trying to do this for some time. The Northeast Visual Hallucination Interview, which was kind of designed for older patients, older neurodegenerative diseases, but it's applicable to everyone. But I suppose the problem is everyone develops their own scale, and there's no kind of consensus as to which one is going to be used, etc. But maybe eventually people will coalesce on one particular scale. I mean, even the Movement Disorder Society in terms of Parkinson's, they've got their own idea as to how this should be measured, which is just a very small subset of UPDRS. But yeah, Daniel, what would you want? Let's say how successful has NEVI been in its kind of world domination?
Well, Daniel has done an immense effort in trying to prepare a paper on the mechanism of hallucination, and then we discuss the different hypotheses. But something smaller, like presenting a scale.
Oh, maybe Daniel's got a glitch because you're muted on my screen here.
Yeah, he's muted.
Well, okay, let's park that thought. But
I think
Marco,
I think
I
there's
agree.
just huge practice of these phenomena. They're pretty sparse and irregular, so you need to capture quite a lot of data, or quite a long time scale, to get a reliable summary. The people experiencing them are often not very good historians, so you're depending upon them remembering things over a period of days or potentially weeks. So I think getting something which is simply good enough to add up from one person to another is really pretty tricky, which is why we do tend to use quite crude measurements. I suspect that probably intensively investigating a smaller number of people, it's a bit like when we've done the functional imaging of people with hallucinations, and you look at people who've got unusually frequent hallucinations. I suspect it'll be using people who've got unusually good recall of their experiences, or can keep a diary day to day, or some kind of time sampling method, which will give us reliable enough data to really work out what's going on in those individual people.
Okay, I'm mindful of the time, so shall we move on, Ella, to our next item?
Yeah, so we wondered here whether we could talk about the significance of the attentional network that was found in the paper to be implicated, and whether this relates to salience and insight into the hallucinations, which is, I know, something that we've touched upon in our discussion already.
So for those of you who don't know, that the big attentional control theories come from the Australian group, from Max Shine and Lewis's group in Australia, and so they've got this nice theory about the attention is a very complex term, and in fact in Daniel's paper we just got told off for oversimplifying the concept of attention, but so the idea is that there's a dorsal attention network, there's a ventral attention network that deals with slightly different things, and then there's our kind of default mode network for internal mentation. And the Australian group evidence kind of comes up with this idea that is a dysregulation between these externally projecting attention and internally projecting attention. There's some kind of dysregulation between it that results in hallucinations. And so in the mega-analysis paper, what we found was a lot of the regions that were showing up fitted into these attention network neural systems that we know are linked to those. So that's why it was mentioned as, or made prominent in the particular paper. Mitul, do you want to say anything about ventral, the different attentional networks?
I don't think I should. I think I can add too much to what you said. There's a dorsal and ventral attentional network, and in Shine's model as well, they linked this function, I think, in the more dorsal network with loss of insight as well. So there's quite a lot of predictions in this model, which is nice, and it's related to how it's thought that dysregulation in these attentional systems really comes into prominence for hallucinations when you've got dysfunction in some of these early visual processing regions. So you can't really deal with the fact that your stimuli are ambiguous very well. And this may actually lead to hallucinations. I mean, that's the core of the model. But I'd quite like to hear what Daniel has to say about it, because obviously he's reviewed this very recently as well with you. It'd be great to hear his additional comments, because I can't say anything beyond what's really been said in the paper, what you've summarised.
I mean, I think that's very true, that attentional factors seem to be key. I think what's interesting is, why should attention be so important? And I think, as other people have already said, it's something about the way that attention combines with visual input, whether that's because of eye disease in somebody who's got Alzheimer's disease as well, or it's something about the visual processing impairments that we know occur in Parkinson's disease or Lewy body disease. And I think there's a lot of stuff we don't know about how those things combine and at what level they combine. I think, having spent together with other people on the panel a couple of years trying to combine lots of different attentional theories into the same framework, what strikes me is, when you do that, an awful lot of the attention that people have focused on actually has its impact on how much sensory data is gathered. So that you could have a very, very simple way in which they combine, is that you've got restricted visual input anyway, or poorly processed visual input, and then you've got bad attention on top of that. So if you've got bad attention, then you're not even, for example, pointing your eyes in the right direction, or focusing correctly, or avoiding distractions. And so you've got even less visual information coming into your brain. And that may well be one of the very simple ways in which these factors interact. And people like myself, who spend quite a lot of time arguing it's much more subtle and it's kind of well downstream in the visual pathway, may have kind of simply missed out some of these very simple ways in which these combine. So I think one of the interesting questions is, if we manipulate attention, what effect does that have upon hallucinations? And one of the interesting things is that hallucinations are very sensitive to changes in attention. So when people are hallucinating, if you distract them, the attention tends to disappear. or if you change the visual input, the hallucination tends to disappear. So it may well be that some of these attentional factors are really having their effect because they're changing the information that is coming into the brain, as well as what they're doing to the information which is in the brain already.
One final thing before we move from attention. So Marco is kind of champion of the thalamo-cortical dysrhythmia type of explanation for hallucinations. And Marco, is that linked to attention? I mean, obviously the pulvine and parts of the thalamus are linked to attention in some way, but do you think that's just another way of looking at attentional problems, or do you think the thalamo-cortical dysrhythmia thing is a separate issue? That was a question specifically directed at Marco.
Marco, I think you might be on mute.
Sorry, it must have gone mute on himself. So actually, I was saying no. Actually, all the idea of the thalamocortical dysrhythmia is that the slow rhythm, which is generated by thalamic interneurons, is first involving the frontal lobes, and only it is the point. The reason why don't we measure on the EEG recordings these early alterations is that because in the frontal lobes you have lots of artifacts, so that's a part of the EEG which is often not attentively observed by EEG analysis because of the interference of artifacts. But we could show that the first development of the theta rhythms, is in the frontal lobes and the dorsofrontal projections. So we do believe that the basic is attention.
Right. Okay. So it's basically maybe those two theories are closer than we think. It's just different ways of measuring attention: the neurophysiology versus the neuropsychology. Okay, I think we got 5 minutes left.
Can I just add to that? Just
yeah.
I hate to draw attention to one of my own papers, but just to say that in the paper we're discussing, we didn't see any volumetric changes or network changes with the thalamus, and that was this. We found that disappointing, of course, because we'd like to have seen that. As I like this idea. But that doesn't. I just want to say that doesn't mean there isn't thalamic involvement, because this paper was only about volumetrics. Of course, it just means that the volume loss in the thalamus isn't noteworthy at this stage, and it doesn't connect in the covariate analysis to the volume variance in other regions as well. So just because we didn't see the thalamus doesn't mean it's not involved. Marco's got his hand up.
May I had a question to ask you. Directly. I've seen that you use FreeSurfer, and FreeSurfer has programs to part for thalamic perturbations. Can't you run?
There's a bit of interference, but yes, please carry on, Marco.
Yes, I mean, the FreeSurfer program is, you can have the thalamic parcellation in 25 thalamic nuclei. So actually you could analyze more deeply the involvement.
Yeah, that's correct. Yeah, we decided in this paper not to parcellate all the subcortical regions, but to save that for a separate piece of work, because the volume of what we'd done already was quite substantial, and that was a separate piece of work. So the same for the hippocampus and the amygdala. We didn't do any parcellation. No, you're quite correct.
And indeed cerebellum.
And cerebellum, yes, of course.
Yeah. So Ella and Jamie, do you think we've got time for one last question? Maybe we can do the technical question about the surface volume and methodology. Yeah. Excellent. Yeah. So I think that leads on quite nicely. It's a FreeSurfer type question. Maybe Mitul, do you want to address this one? What's the significance of assessing cortical volume and surface area?
Sure. I mean, well, we're running out of time. So quite briefly, you can look at volume, or you can separate volume into the surface area multiplied by the cortical thickness and measure them separately. Those two things, cortical thickness and surface area, are orthogonal. They have different developmental genetic controls, and they're different in neurodegeneration as well. So, for example, the best correlate cross-sectionally with volume is surface area, but during neurodegeneration, it's cortical thickness change that correlates with volume loss best. Okay, so it's very important to separate them out and look at them individually, because we expected to see different things because they're under different controls. And so, in fact, we did see a lot more changes in cortical thickness than surface area, and the networks and the communities linked to cortical thickness variation don't fully overlap with those with surface area as well. So, and also the associations with the receptor profiles. Well, we didn't really look at it with surface area because we didn't have sufficient regions different as well. So again, it emphasizes the value of separating them out.
And Mitul, can I just check? So I think I'm right in saying that the surface area is linked in some way to the underlying white matter atrophy and how big a particular gyrus is or something like that. So that will influence the surface area as well.
Correct. Yeah. So that's one. The evidence isn't super duper, but there is some evidence that indeed the surface area does link to the underlying white matter tracts, which you can imagine in relation with development. You can imagine how that might happen, how that might be strongly linked. Yeah.
Okay, I think you've answered it perfectly. I'm going to hand back to Ella and Jamie to round it off. But I think we almost did most of the questions. Not everyone. There's some interesting snippets still out there, but I think we've had a very rich discussion anyway that I very much enjoyed. Anyway, I'm going to pass back to Ella and Jamie.
Brilliant. Thanks very much, Dominic. Yeah, I think it was slightly ambitious to try and get through 8 discussion points, especially when we had such interesting thoughts on all of them. So I think we've just got a final slide or two. Ella, if you're able to get that up. So it's just to close up.
Wanted to thank you all again for joining, and a special thanks to our panel members and for Dominic for being such a good chair. We've also just wanted to mention our website, which has been made by one of our trainees, Hamilton, who I think is on the call with us today. And this is where we'll be advertising our future journal clubs. This will also be advertised on our Twitter page, and Eddie has a very effective control of mailing lists. So we hope we will reach it to you by some means, and that will be coming soon in the spring. So thanks again very much, everyone, for joining, and yeah, have a lovely weekend.
Thank you.
Thanks for the invitation.
Thank you all.
Thank you. Bye.
Thanks.